Last time we've built what this game calls a Turing Complete machine, which of course isn't actually Turing Complete, but nothing is really. Yeah, we built a potently working computer, but it's still a pretty bare bones computer. We have just some program we cannot interact with, and inputs and outputs that were not really useful. And I'm hoping the programming section can help us out, at least with the second part of my issue. With, wait, was it the first or the second part? Whatever. Basically, I expect to get the ability to do stuff on the computer. So, let's see. Add 5. You have built your computer, but to win the competition... No, I have not won the competition yet. The elephant is still... The elephant is still alive and kicking. But to win the competition, you still have to finish the maze. I don't remember him talking about the maze. There was no maze. Wait a minute. Wait a minute. Look at this. Look at this. I'm being tricked. Good luck. Build a functional computer or you will be eaten. I've built a functioning computer. It's functioning. It's not just functional, it's already functioning. Well, I cannot make it function, but it functions. I must not be eaten. Ah, darn aliens. Really can't trust them. Alright. Looks like I still have to finish the maze. Am I gonna be implementing a star or whatever in assembly? Since you don't know how to program it yet. You're not quite ready for that. Yes, I'm not. So in the meantime, we will have you help out on the ship a little. Cool. Click on the edit memory icon on the program component to start programming your computer. Your computer should read an input, add 5 to it, and output it again. No need to worry about overflow. Thanks. Notice that I don't even know what's gonna happen with overflow in my computer. I don't remember. I think it's just gonna be ignored. Yeah, I have a single byte thing. I'm gonna add to a single byte thing and I'm gonna get a single byte thing out. So notice that the immutable red register components have been replaced with a custom component with identical functionality. Are they mutable now? I can move them. Can I mutate them? What's up with this? Is this? Oh, that's a memory probe. I don't really know what it does. Oh. So that... I don't know at what point I'm supposed to figure all this out. Was I supposed to already know how this works? Show values on custom components. Link values to the program component. What does it mean to link values? So this links components. Does this have any effect other than what I currently see? Like, if I... Oh. Wait. Clicking off it just disables it. So I was wondering, if I enable it and then I exit, does that actually change my component? Or is this just a visual display thing? What? Whoa. Okay. So I guess... And I guess this memory probe gets displayed right on here. I suppose. Okay, cool. Cool, no problem. So, I'm not gonna squish it yet, but I feel tempted to squish it. Also, the playing field is now mega huge. I can fit a megabyte in here. No, I probably can't. Can I? It's a million. I don't want to calculate it. Probably not. Probably not. Okay, so add 5 to the input. Let's see what the edit memory. Oh no. Instruct. I'm gonna have to flip bits by hand. Oh, this is the old MX butterfly trick. To those who will understand the reference. Okay, but it looks like I can clone something from somewhere to somewhere. Read the manual page. Yeah, this is edit instructions. Oh, okay. So you complete the level Turing Complete. The instruction panel allows you to manually edit instructions. This is useful if you wish to build your own computers. Just finish the over to your computer and see something weird. Odds are you may have changed the definitions. See something weird where? The definitions of what? What definitions are there? You may have changed the definitions. Definitions of the instructions or condition, never, or. Okay. Each row has a label and 8 bits you could set to either. Oh, this. No. What? Which row? Which row where? Reset. Cool. So I'm guessing this is what they mean by change the definitions. It's curious that they're not labeled or anything. But I can add my own. I don't understand what's up with set to wildcard. There's no such thing as a wildcard that can be set in the computer, right? A wildcard is just useful for my understanding of what's happening in the computer. You only have concrete bits. So you complete the level. I don't get it. Okay, let's see. Let's see what happens if I press copy. Oh. Oh, I just clone multiples of it. How is this? This is not useful. What? Clone. I don't. This is not. Well, it's. I'm not gonna say it's completely useless, but the thing I want to avoid is I want to avoid flipping bits one by one here. But it looks like I'm gonna have to. Right, I was hoping that maybe I could copy from here to this byte. Okay, alright. This does feel like my first assembly challenge. Baby's first assembly program. Hello 5. I like to call it. Test 1 of 32. Okay. Okay, how on earth do I do this? So I need to use, at some point, maybe not immediately, but at some point I'm gonna need to use my calculation mode. So let's go there immediately. Copy. Compute. Calculation. Compute. It's curious that here it's called calculation and here it's called compute mode. So I'm gonna want to apply add. Right? At some point. Wait, I closed my RAM. Is this called RAM now? No, it's called program. Wait. Does program stand for prog RAM? There's no way. No. I think that's just me making non-existent connections. Program. View instruction definitions. Yes, this I've seen. I've seen this. So, it's okay. I have a huge table. So I have. How do I even? Where do I start? Okay, let's say. Let's add more pieces of interface into the equation, and let's try to first write it in pseudocode. So my addition, do I have it in the manual? If I remember correctly, I probably do. I don't think I need the manual. My addition will take stuff from these two, from register 1 and 2, and it will put it into register 3 always. So in order to add anything, so we do have an add step, right? We do have an add step, but first we need to load inputs into 2 and 3, reg 2, reg 3, right? We want to do this first, which is probably going to be multiple steps of its own. Then we add, wait, reg 1 and reg 2, sorry. Reg 1 and reg 2. Once we have loaded the inputs into reg 1 and reg 2, we're gonna add them. Once we have added them, we'll have our output in output written in register 3. And now that we have it in register 3, we pipe it to the output, if I remember the problem statement correctly. Click on the edit memory, yes. Wait. What? Read an input, add pipe to it, and output it again. Yeah, sure, cool. So after we add, we out reg 3. And this is the end of our program. Do I need multiple steps to load into reg 1 and reg 2? So I have input? No, I don't, as a matter of fact. Well, kind of. I need to... Okay, there's gonna be more, because I only have one input, basically. So I guess we can start with that for now. So we copy input, I don't know, I'm using whatever notation I can come up with. Copy input to register 1, let's say, right? This is going to be our first thing. But then we need to, you know what? Just because it's not actual code. Oh, not used to. Come on, leave me alone. Now that we also need to add 5, but in order to have a 5 in my register, I actually need a constant 5 inside of my... Wait a minute. What does direct mode do again? Or immediate mode? So immediate mode... saves into... Yeah, it saves my... Yeah, it saves the current thing into register 0. But my ALU will not read register 0, so actually there's even more steps to this. So register 1, well, let's say register 2, just because I feel like it. Oh no, now it's gray. Please be white again. Thank you. So first I need to do immediate 5 into, well, immediate 5, this will put it effectively into register 0. And now I need to copy register 0 into register 1. Probably shouldn't use a space between these reg numbers, but I've already been doing that, so let's keep it that way. Okay, is this our program? So we start by copying a 5. We copy input. This will do one thing once. So I'm not looping, right? If I need 32 tests, I would also need a loop, which I wouldn't be opposed to implementing right now. I think I could do it. But I think they're not asking that of me for now. So again, we take immediate 5. We are in, oh, it's called register plus now. Curious. So it's going to be in register 0. Now we copy, oh, it's not copy input, it's copy register 0 into, did I never write it? We copy register 0 into register 1. Then we take the input, we copy it into register 2. Then we do ALU. It writes it out into register 3. Right, this is output written. Yeah, so gonna be my notation for written 2. And out register 3. Yeah, so this is actually copy. Properly it would be called a copy register 3 to out. Yeah, I can already feel assembly creeping up. Right, you'd have like CP no reg 3 out. Or actually, knowing assembly, it's gonna be CP out reg 3 because assembly, because whatever it was, Intel versus whoever it was, AT&T. I don't. Yeah, there's some weird guys there that are not actually a modern name we know. Cool. Immediate 5. Don't even. So this is our program. I think this is our program. Do I remove the arrows already? I'm gonna remove the arrows. I'm coming up with my own assembly here. I should look up the different assembly notations. You know what? I'm gonna do that right now. Yep, exactly. There's two styles. There's Intel and AT&T. And this right here is effectively AT&T. So you have source on the left and destination on the right. Register 3 to register out. Oh, register out. While in Intel tradition for syntax of assembly, you have copy to out from register 3. So you put your destination first. And it's I believe there's more than copy that's affected by this. Okay, so now that we have our program, we can start flipping bits using the old MX butterfly trick. Let's see. I need immediate 5. That's no problem, except what's the immediate? Cool. Yeah, so just 0 this and we have immediate 5. Now I need to I'm gonna encode instructions first. So I'm gonna say copy, add copy. What's my copy? Copy is green, red. So copy, add copy. What's my add? Compute, red, green. Sure. Now we need to copy register 0 to register 1. Copy. Now this condition copy. Wait. What? Why are these copy instructions weird? Copy. Also, I can edit this for some reason. I don't get this page. I definitely remember that copy had... No. Yeah, no. I definitely remember that copy had 2 operands in the same instruction byte. Why do these bytes have question marks? I don't understand. And also, I don't really get why I would need to... Yeah, I really don't understand this page. It's useful, sure, but it's not great. So, yeah, I want copy. Yeah, see register. I think I could just... It would just be easier for me to use this instead. So copy, I need register 0 to register 1. And my output, by the way, is on the right. I think I complained about it being on the right before. Yeah, and now I'm not. Well, I can still complain because you read the byte right to left, you don't read the byte left to right. So this is kind of position 0, and maybe that's where Intel is coming from. But yeah, we need to copy register 0 to register 1. Let's double check. Let's see. Yeah, this is the output. Wait. Yes, this is the output. Register 0 to register 1. So this is our copy. Now let's copy input to register 2. So register 2, what's input? Oh, I think this was input. Cool. So register 2 input. Now we add, but we add register 3 compute. Well, yeah. So I could kind of say compute add register 3. So I have my mode, my opcode, and this is not actually, this is just for my convenience. Okay, so what's addition? I don't remember. And add, okay. So we add to register 3, and then we copy again, register 3 into out. Cool. I think that's it. That's our program. 5, 129, 178, 68, 158. Gödel's incompleteness comes to mind. Let's test it. That's very slow. That's surprisingly slow. Also, a new sound effect. Let's do one. Oh, wait. Okay, yeah, so our program actually takes multiple steps to calculate, multiple ticks. Yeah. But a full test is multiple ticks. And this, I assume, the sound signifies a reset. But we're done, because we don't actually have any looping behavior in here. I think I could implement it pretty easily. I think it might just be one instruction or something. I have... Well, no, it's not one instruction. Although... I would need to jump to 0. Where does the counter take the... Oh, it takes... it takes the value from register 0. So no, I would have to write 0 to register first, and then reset the counter. Okay. That's cool. That's cool. We're good. Let's listen to the sweet sound of success again. Test. 32. It's pretty slow. Code IDE. Name codes and edit them in a convenient editor. Right. I've seen this in the trailer. I think I've seen this in the trailer for the game. Assembly. You can use a mix of assembly codes and numbers to set the bytes. Assembly codes are just synonyms for a bit pattern. I see. For example, instead of typing 196 for add, this code can be named add directly, simplifying reading and writing code. Comments can be added using whatever the sign is called, hash. Additionally, the const keyword can be used to name a value within a specific program. There's no way that's in any actual assembly. No way, right? There's no way you have such definitions in real assembly. Okay, label assigns a name to the byte offset of the line it was inserted on. Ah, that's helpful, and actually I think that might exist in actual assembly. Does const? Okay, I'm gonna get back to this once I'm done reading the page. So you can add, subtract, multiply, integer, divide, modulo, OR, and XOR values together using these things. Sure. Breakpoint points can be added by clicking. Wow, an IDE can be added by clicking to the left of a line number. Program will automatically pause at breakpoints when running. Okay. I'm wondering, first of all, does it have Vim mode? Does the IDE have Vim mode? Because I want to be able to edit it effectively. And also, is it possible to open it in an external IDE? Is there a language server protocol for this? I doubt it. Okay, breakpoints can also be added to any of the linked components, pausing the program when the state is changed. Click on the state and you will see the red dot. I don't get it. To any of the linked components. What are linked components? Points can be added to any of the linked components. IO level screen. I don't get it. Finally, values can be specified in binary with the prefix 0b. Sure. OB, O1, O1, and hex with the prefix. I will probably never in my life understand the people who use hex notations for specifying integers and bytes and stuff. I understand decimal. I can understand binary. Why on earth you would use hexadecimal? I have no idea. Like, sure, I can translate it into binary. I can kind of translate it into decimal in my head. But that is an enormous amount of effort for me, and I do not get why would you even do it in the first place? Okay, so what I was going to say here is it really looks like we're diving more and more into assembly. Let's take a look at the IDE. I think we should get it in the next level. Okay, link components, edit memory. Right, here's our IDE. Whoa. No, I'm not gonna read the actual statements. Okay, so this is our IDE. There's no option to open it in Vim, although there are tabs with different programs. Are you sure you want to delete? Yes. Okay, I wonder if Control W will close the tab. No, it doesn't. So Something I have been thinking about for the longest time, actually, probably even before starting this game, ever since I saw the ID in the trailer. It looks like I can just create my own assembly, right? Basically my own assembly syntax. And I can name it whatever I want. But I think I would personally prefer to try to use conventional notation for stuff, which I do not know, and I would have to look up. But I think I would probably like to look up something like ARM assembly notation or x86 or whatever. I don't know. I don't know how assembly works. What's it called? There's those two. What are they? There's like two acronyms for two big important assembly languages, which I cannot for the life of me remember. WASM is WebAssembly, but that's not quite it. Is it YASM and something else? So yeah, I'm probably not gonna do it in this video. Please do tell me if you're strongly opposed to me looking up actual instructions and actual conventions to use, but I probably would, starting next time, apply conventional notations. I'm not sure which variant I'd use, but that I can look up. Alright, so let's proceed with this level. We need to calibrate laser cannons. Oh no, this actually looks like a complete... What is 2 pi times 1? What do you mean, what is 2 pi times 1? I cannot represent pi with any kind of precision. Well, actually I can. But, okay. On our ship, we naturally shoot incoming asteroids with lasers. Naturally. In order to calibrate said laser, we want you to calculate the circumference of the asteroids using an advanced equation. 2 pi r. Wow. R is the input, and you can approximate... I can approximate pi as 3. Send the answer to output when it has been calculated. Also, you now have access to assembly programming. It allows you to add names for instructions, so you can add, for example, type add instead of inputting 68. Sure. I'm assuming 68 is the alias, or is the bit code for the instruction add. Cool. It's really interesting to me what this is. Screen shows visuals of the levels in the main campaign. This is intriguing, but I don't actually interact with it in any way so far. I guess it's showing me the radius. Is that the radius of my... Wrong. Must read input before outputting. That's a weird suggestion. Okay, so edit memory. Can I rename this? I can. That was... What was this? No, this... What is this? I am a comment below calculates 1 plus 1. Right, so this is not my previous program, so I don't care about any of this. Asteroid... What are we calculating again? Circumference? Yeah, circumference. So if I can spell the word circumference. circumference. Cool. Circumference. Dot overture machine language, OML. Sure. Okay, let's see here. We have our input, we have 2 pi times 1, so we need to perform 3 multiplications. How do I even multiplicate? How do I even multiply? I don't have a multiplication primitive in my ALU. I don't. So it looks like I'm just gonna have to perform 6 additions. Which, I mean, considering I'm programming in assembly, I do not feel ashamed writing add. I think this is perfectly what's the word? A perfectly idiomatic assembly program. Okay, so this is gonna be my addition situation. But I can, by the way, I am free to assume that my registers are zeroed out when I start, right? So I don't like how the IDE closes every time. Right, I like to just click on things randomly and I don't want to reopen the IDE every time. Also, I would still like to resize the window. Okay, whatever. So before I start my addition, I need let's say, so we're outputting into 0. No, yeah, 6 additions is not going to be enough. I will need to copy my thing back. Well, it should be fine. So need input in, well, let's say register 0 and 0 in register 1, which we already have. Once we have added, I actually also will want to do register 3 to register 1, and I will want to do that 1,000,000 times. Hello? I cannot add. Oh, okay, it's off screen. Give me the manual. Give me the instructions. So I need to copy register 3 to register 1. Copy register 3 to register 1. 153. Like so. 153. So this is register 3 to register 1. See. Right, so now that I've done that, man, having no Vim controls sucks. 1, 2, 3, 4, 5, 6. Lovely. Register 3, I will not need this final one. This will actually be my register 3 to out. Right? And now that we have all this, input in register 0. So we need to input to register 0. Wow. Okay, copy input to 0. I'll call it in to register 0. Right, so I want in to register 0. Wait, did I actually set it to the correct thing? I never did. Enter register 0, save, perfect. Okay, so we have our input, we have it copied to register 0. We know that register 1 is 0 by default. So we'll add them up. They'll go to register 3. Wait. Did they go into register 3 or register? Yeah, they go into register 3. So yeah, I'm still slightly confused by why addition is offset like that. I don't have a problem with it, right? We are using register 0 for other stuff. But I think it could work. Oh, sorry. I think it could work otherwise. Wow, there's so many buttons now. I'm just constantly lost. And I always want to see my computer. Okay, again, so we have our... No, input not to register 0. Input to register 1 I need. Input to register 1. And this I need register 3 to register 2. Do I not have such a... Register 3, copy, register 3 to register 2. 2, save. Okay, 1, 2, 3, 4, 5, 6 times we do that. Is this correct now? Input, no, this is not, because input to register 1. Then we add, we get our input in register 3, and we put it back to register 2, then we add again, and we do that 6 times, and then we output. I think this is good. Okay, what do I see? 1 cust, 2 cust. So these are my breakpoints. What? 7? What is this? No, where was my breakpoint tutorial? ID? Assembly? Okay. Wait, no, I can place breakpoints here somehow? It was supposed by clicking to the left of a line number. Okay, you have to be really far to the left. Alright, so I have these breakpoints, that's fine. What's up with these? Link components. To any of the link components. 0 cust. Cust. I don't know what all this is. Using the program when that state is changed, so maybe. So let's see, we have 0 1 1 1 0 0. 0 1 1 1 0 0, and then what's 6 and 7? I have 5 registers. No, I have 6 registers, sorry. That's okay, and that's probably it. And that's probably my link to the stuff that's inside the register. And I'm guessing maybe 6 and 7 is in and out. Oh, 6 is out and 7 is custom. I don't know. But we are calculating asteroids just fine, it looks like. Man, that's one rough approximation. For these shapes, first we approximate them as a circle, then we approximate pi as 3, and then we calculate their circumference for some reason. Not their area, but their circumference. Okay, Robotron 9000 plus. Nice. Cool. Cool, this sounds exciting. I'm gonna be controlling Robotron using my own assembly. Although probably it won't be my own assembly next time. That said, I am already worried because it looks like I can only define singular. You know, what do you even call it? So I can only define the token with no spaces. 0, 1, 2, 3. Oh, cool. It helpfully also tells me the number of an actual line, ignoring comments and white space. So I wonder if I can name something. So let's say this is going to be my copy. And let's say copy 1 to 2. Right? Can I name it CP? No, I cannot. I cannot add a space in here. So I can only say move underscore BA or something like this. Again, I'm not sure what the actual thing would be. XB AX. I don't know. I don't remember. But mov is, I think mov is right. Okay. Guess we'll find out. But we will find out next time.